Notes 1.5. Geometric properties of linear functions. Let's go ahead and read example number 1. You need to rent a car for 1 day to compare the charges of 3 different companies. Company 1 charges $20 per day with an additional charge of 20 cents per mile. So Company 1 initial charge is $20 and 20 cents for every mile. Company 2 charges $30 per day with an additional charge of 10 cents per mile. And then Company 3. Company 3 has a flat rate of $70. So it says for each company, find a formula for the cost of driving a car M miles in 1 day. Well, I just did that. C in terms of M. Then graph the cost functions for each company from 0 to 500. Okay, so let's go ahead and draw an XY axis. And in this case, we're not using X and Y. Our independent variable is M, and C of M is our dependent variable. Okay, so they want us to go from 0 to 500. 0 to 500. You can just estimate. I'm going to go by hundreds. 100, 200, 300, 400, 500. Okay, so 100, 500. All right, and then our y-axis here, I think I want to go by hundreds. Let's go by tens. Okay, let's go by tens. So let's say I call this, let's start here. 10, 20, 30, 40, 50, 60, 70, 80. There we go. 10, 20, 30, 40, 50, 60, 70, 80. So we're going by 10. They don't have to be the same on the x and the y, as long as they're equal increments here, equal increments here. Okay, so let's start by plotting the first graph. Our y-intercept, or our initial condition, is 20. And you really only need to plot 2 points to determine a unique line. So if we want to do, say, 500, if we want to plug in 500 into the equation, it'd be 20% of 500, or 500 times 0.2, which is 100. And then you add 20, so we plot this as 120. But that's going to run off our graph, so let's go with something smaller. Let's go with, say, 300. If you plug 300 into this equation, multiply that by 20% or 0.2, you get 60, plus 20, you get 80. So 380 is the point on the first graph. So we're going to estimate that to be about right here. And again, it is just an estimate. So let me connect those with a line. And there's our C1. Let's do the same thing for C2. C2 starts at 30. Okay. And how about if we plugged in 500 for that one, or 400? It's completely up to you. Let's do 400. 10% of 400 is 40, plus 30 is 70. So if we're plugging in this one, we would get approximately here, which is 70. Okay. that. And there's our second line. And then the third one, our third company is always $70. Always $70. Okay. I missed that a little bit, but we're okay there. You get the idea. Okay, so there is the graph. It says, how many miles would you have to drive in order for company 2 to be cheaper than company 1? Company 2 to be cheaper than company 1. Well, let's see. Let's see when they're equal to each other. Let's find this intersection right here. What does it look like? About 100? Oh, let's see if that's right. If we do company 2 equaling company 1, all right, subtract 20 from both sides, you get 10. Subtract 0.1 m from both sides, and you get 0.10 m. Divide by a tenth. Dividing by a tenth is the same as multiplying by 10. So you're going to get m is equal to 100. So that's when they're equal to each other. Okay? So as you can see, the pink, after that, the pink, the second company, is going to be less than the first company. So you would have to travel more than 100 miles for company 2 to be less than company 1. And you can see that on the graph. Okay. All right, so using slopes and y-intercepts, see if you can match each one of these formulas or equations to one of these graphs here. You can stop the video and try it now. All right, let's see how you did. B, A, C, D, and E. Y-intercept, slope. Y-intercept, slope. So how do we know which one is slope of 2 and which one is slope of 4? Well, let's take a look at these facts here. What are the facts about the line that's in y equals mx plus b form? Well, if you didn't get those right, review these facts. The y-intercept, the b, is also called the vertical intercept, tells us where the line crosses what? The y-intercept is where it crosses the y-axis. When your slope is positive, the line rises left and right. So as you read the line, is the line rising? Or as you read this way, is the line falling? When the slope is less than 0, the line falls left to right. Now, how do you know which one is steeper? How do you know if this is 2 or this is 4? Well, when you take the absolute value of the slope, the larger the value, the larger the absolute value, the steeper the graph. Okay. Next is a review of parallel and perpendicular from geometry. So we have two lines. We'll call this y sub 1 and y sub 2. Slope 1, slope 2. Okay, what do you know when two lines are parallel? Well, when they're parallel, they have the same slope, but they would have different y-intercepts. Same slope, same y-intercept, same line. How about perpendicular? What do you know about perpendicular lines? Well, their slopes are opposite reciprocals of each other. So basically, change the sign and flip it over. Okay? Let's look at a couple examples here. It says, consider the lines at the right. We know that this line right here is -2. It says one of the lines is -2. Well, I know that this is a negative slope and this is a positive slope. So that slope is -2. How about the slope of the other line? Can you find that? Well, they give us 2 points here. This point right here is 0, -2, and this point right here is 2, 0. You could use the slope formula, or you could just count. Rise over run, 2 over 2. So we know the slope of this one is equal to 1. Now we also know the y-intercept here is -2. So if you know a y-intercept and a slope, you would use slope-intercept form. And again, a review of slope-intercept form is y equals mx plus b. That's slope-intercept form. So for line 1, we'll call this line 1 right here, the positive one. For line 1, our slope is 1, so it's 1x plus the y-intercept, which is -2. So plus a -2, you're just going to write x minus 2. There's your equation for y sub 1. Let's do the equation for this one. We'll call this line y sub 2. Y sub 2, we're going to use the slope-intercept because we know the slope is -2, and we know the intercept is +3. There's your equation of the two lines. Now the question is, find the exact coordinates of their point of intersection. Well, as you can see here, it's not very obvious. We know it's less than 2 and below 0, but we don't know what it is. Exact means leave your answers in fractional form. Okay, so to find the solution, or the point of intersection, you're finding the solution of this system. And because they're both solved for y, we're going to go ahead and we are going to use substitution, or basically substitute this into here, or just set them equal to each other. So when are the equations, or the lines, equal to each other? So solve for x. If you want to stop the video and try it yourself, you can. We are going to add 2x to both sides. We are going to add 2 to both sides, and we are going to divide by 3. So that is not the answer, that's the x coordinates, that's the x value of this point right here. Does this 5/3 just a little bit less than 2? Yeah, sure is. But now we need the y value. So the y value, you can substitute x into here or here, it doesn't matter. I'm going to use the first one. Y is equal to 5/3 minus 2, or y equals 5/3 minus 6/3, so I can get an exact answer. No decimals, no calculators, got to get used to that for calculus. So that would give me a -1/3. So my solution is the x value comes first, then the y value. My solution is 5/3 -1/3. Okay, so a little bit less than 2, a little bit below the x-axis. That is your point of intersection, or the solution to the system. Okay, take a look at the last two here. This one wants you to find the equation of the line that's parallel to 2x minus 3y equals 2. So that means they have the same slope. That means they have the same slope. So in the last section, I showed you a shortcut. If you have an equation in standard form, ax plus by, so your b is negative, plus by equals c, you could find the slope by taking the opposite of the a value divided by the b value. So the opposite of your a value divided by your b value gives you 2/3. So in this problem, I have a point and I have a slope, but I don't have the y-intercept. I have a point and a slope. So on this one, you should use the point-slope formula, which, just as a reminder, y minus your y value equals your slope times x minus the given x value. So in this case, y minus our given y value is 1. The slope is 2/3. X minus our given x value is 1. And that is the point-slope form of the line, which is acceptable if that's what they ask you for. Sometimes they may ask you for the slope-intercept form. So all you would do is you would take this and you would solve for y. So we will do that quickly here. Multiply by 2/3. We're going to multiply this by 2/3, and we're going to add the 1 from the other side. So slope-intercept form would be 2/3 x. That's going to be 3/3. 3/3 plus a negative 2/3 gives you 1/3. That is the slope-intercept form of the line. But when you're given a point and you're given a slope, plug in the point here, plug in the slope here, and that is the equation of the line. So let's see what we have on the last one. Yep, same thing. We know a point, and we know the line is perpendicular, not parallel, but perpendicular. So over here, when it was parallel, the slope was 2/3. But on this one, the perpendicular slope is going to be the opposite reciprocal of 2/3. And we have a point and we have a slope, so we are going to plug that into point slope, just like we did on the last example. So there's your point slope form of the equation. Solve for the y. A negative times a negative is a positive 3/2. I'm going to add this 1 from the other side. So I get y equals a negative 3/2 x plus 5 plus 5/2. Almost wrote 5/3. Plus 5/2. 2/2. You get 5/2. Now, what if they asked you for standard form? You go from point-slope form, you go to slope-intercept form, and then from here, put it in standard form. Standard form, the x's and the y's are on the same side. The most important thing, though, is that you can't have a fraction for your a and your b. So we can't have this here. So what do you think you would do to get rid of a fraction? Multiply both sides by the common denominator, which is 2. So that's going to give you 2y equals a negative 3x plus 5. Add 3x, move the x and the y to the same side, and that is standard form. Or 3x plus 2y minus 5 is sometimes also referred to as standard form, which I think your book uses this, but most books use this. Either one is acceptable for standard form. If it's multiple choice, they will have one or the other. And that is it.